So they have told couple of things to do, like create a GitHub repository. I have created that. Create a virtual account. I have already created that. Connect and deploy your project. You can check in my previous stream. So now create a Postgres database. So we have also done that, and after that they have told us to seed your database. So this is a command I have added in my package.json scripts seed. Then after that you have to run npm run seed. I've already done that. So you should see some console log message in your terminal. So let's see if it's working. Our connection, I think there's a connection problem. Okay, now it's excellent connection. So they're saying that you can go to your database, looks like, and go to Versal. Click data on side. Now in this section you'll find 4 new tables: users, customers, invoices, and revenue. You can view its record and issue entries align with the data from placeholder. Okay, finally it opened. So what they're saying, we have to go to Versal and go to data. Where is the data? I think data should be here. To first select our database, and then okay, here is the data. Browse, choose a table. Okay, it's connecting now. Connected. Okay, we have this users table. Let's see what it has. Okay, so this is the customers. Okay, these are customers table. This is ID, name, email, image, URL. So you can see in our placeholder data, this was all the data of customers. Now it's in our Postgres database through this c.js. Okay, right. Now what? Executing queries. You can switch to query type to interact with your database. This section supports standard SQL commands. For instance, inputting drop table, delete customers table. So be careful. Let's run your first database query. Paste and run the following SQL into Versal interface. Okay, let's curate. Run query. Select invoices.amount, customers.name from invoices table. Join customers on invoices customer ID where invoices amount is equal to 666. Run query. Okay, it's running the query ran successfully. So this is a record it had given us. Amount is 666 and name is evil rabbit. Okay. So this is a SQL. We should also learn SQL, right? It's time to quiz. Yes, the query belonged to this evil rabbit. Okay, we have completed chapter 6. Now what's next? The database now set up and created, you can continue building your application. Next up, fetching data. Let's discuss different ways you can fetch data from database, including using APIs, SQL, and alternatives. Okay, fetching data. Finally, we are making some progress. In this chapter, we will learn about some approaches to fetching data like APIs, ORM, SQL. How server components can help you access backend resources more securely. What network waterfalls are. Fetching runs. Getting some. Okay, now connection is excellent. Let's do choosing how to fetch data. API layer. API or intermediary layers between your application code and database. There are a few cases where you might use an API. If you're using third-party service that provide an API, if you're fetching data from client, you want to have an API layer that runs on server to avoid exposing your database secrets to client. We create in Next. We can create API endpoints using route handlers. Okay. Database queries. Postgres, you can do this with SQL or an ORM. Next generation Node.js and TypeScript ORM. Prisma unlocks new level of developer experience when working in database thanks to its intuitive data model, automated migrations, type safety, and auto completion. We should also learn that. Okay, now data. We will run some database queries. There are a few cases where you have to write database queries. When creating your API endpoints, you need to write logic to interact with database, of course. When you have a backend, you want to interact with database with some API endpoints, you have to write some logic in APIs. If you're using direct server components fetching data on server, you can skip API layer and query your database directly without risking exposing. So that's a big thing about React server components, that you can skip the API layer. You do not use. You can directly query your database directly in the server components. That's great. Okay, that's why you should not query database directly which data on client, as this would expose your database secrets. With server components, now let's learn something about server components. By default, Next.js application uses React server components. We have also read about that. Fetching database server components is a relatively new approach, and there are a few benefits of using them. Server component supports promises, provide a simple solution for asynchronous tasks like data fetching. You can use async awaits index by reaching out for libraries. Right, great. Server component execute on server, so you can keep expensive data fetches and logic on server and only send the result to client. Cool. Cool. As mentioned before, since server component execute on server, you can query the database directly without an additional API layer. It's time to take a quiz. Without the API layer, we can access the database using SQL. Okay, now we are going to use SQL. For your dashboard project, you will write database queries using Vercel, Postgres, SDK, and SQL. There are a few reasons why we'll be using SQL. SQL is industry standard for querying relational database. Having a basic understanding of SQL can help you understand the fundamentals of relational database, allowing you to apply knowledge to other tools. SQL is versatile, allowing to fetch and manipulate specific data. Vercel Postgres SDK provides protection against SQL injections. Don't worry if you don't have SQL before, we have provided queries for you. Now go to applibdata.ts. Okay, applibdata.ts. Let's just close these tabs. Okay, it's empty. First, we need to import SQL from Vercel Postgres. Let's sync. You can call SQL inside any server component, but to allow you to navigate the components more easily, we have kept all the data queries in data.ts file. You can import them into components. Okay. What does SQL allow you to do in terms of which manipulate specific data? Okay. Fetching data for dashboard overview page. Fetching data for dashboard overview page. Now you understand different ways of fetching data. Let's fetch data for dashboard overview page. Navigate to app dashboard page or tsx, paste the following code and spend some time exploring it. Okay. Dashboard. Okay, we have to copy all this code and paste it here. Okay, they are saying us to explore this code. So this is a code. We have first imported card from dashboard cards, revenue chart, latest invoices. We will see that later when we import that. This is a dashboard. Okay. Let's go to dashboard page. What's inside it? Dashboard. Okay. So they have wrapped it inside main. So what's next? An async component. This allows you to use await to fetch data. Okay, they have used async with the page. This is a server component. We can use async await. Okay. There are also three components which receive data: card, revenue chart, and latest invoices. They are currently commented how to prevent application from erroring. Okay. Fetching data for revenue chart. First we will fetch the data for revenue chart. To fetch revenue chart, import the fetch revenue function from data.ts. app lib. Okay, we will import this into our dashboard page tsx, fetch revenue. Then inside this we will make a variable named revenue, and we will use fetch revenue inside this. Okay, then uncomment the revenue chart. Oh, wait, that was my error. So SQL is imported. So let's go to this. What they are saying us to uncomment, to then uncomment revenue chart component, navigate to component file tsx and comment the code inside it. Okay, we have to also uncomment of code from revenue chart .tsx. Okay, they have put the components in various folders. So UI, dashboard, revenue chart. We will uncomment this code. Okay, uncomment this. So I think our code should be working now. Great. So we are getting data. Okay, this is a revenue chart. If we go to our Postgres in the Vercel, so it's connected. Let's go to invoices. So this is invoices, this is amount. Okay, so this is the data it is getting and showing this here. So revenue chart, revenue, and fetch revenue. We are using fetch revenue from this. Where is the fetch revenue function? Fetch revenue. Let's explore where it is in this. Okay, this is fetch revenue. So they are running this command data await SQL revenue select star from revenue, select all data from revenue, return data.rows. Okay, it is returning the rows from our table. So there's so much happening right now. This SQL is automatically connected to our fetch revenue. So we are actually making a backend request, right? Cool, man, cool. So what's next? You have to see a chart that uses revenue data. Okay, we have that exact chart in our local host. Let's continue importing some more data queries. Fetching data for latest invoices. Now it's turn for us to fetch the data for latest invoices. For latest invoices component, we need to get the latest 5 invoices sorted by date. You could fetch all invoices and sort through them using JavaScript. This is not a problem as our data is small, but as your application grows, it can significantly increase the amount of data transferred on each request and JavaScript required to sort through it. Instead of sorting through latest invoices in memory, you can use SQL to fetch only the last 5 invoices. For example, this SQL query from your data. This is a SQL query from your data.ts file. Okay, it selects latest invoice raw. Select invoices amount, name, image URL, email from invoices. Join customers on invoices, customer ID. Order y invoices dot date in descending order. Limited to 5. So inside our page, we will import this. Okay, this is a function we have already used. Now again, we will write a variable and you will use await, then use this fetch latest invoices here in our page component. And I think next is we will uncomment this latest invoices. Uncomment latest invoices component. You will need to uncomment relevant code in the latest invoice component itself, located in dashboards, UI dashboard, latest invoices. UI dashboard, latest invoices. So I have to uncomment this code. So if I go to this, okay, right, we have our latest invoices. That's great. Now let's okay, we have uncommented this latest invoices component. Now if we will visit our localhost, you can see only 5 returned are returned from database. Hopefully you're beginning to see the advantage of querying a database directly. Okay, right. Ta for the card. Okay, practice. They are saying us to practice it. Fetch data for the card component. Now it's your turn to fetch data for card components. These cards will display following data: total number of invoices collected, invoices pending, total number of invoices, total number of customers. Again, you might be tempted to fetch all the invoices, customers, and use JavaScript to manipulate the data. For example, you could try array.length to get the total number of invoices, customers. But with the SQL, you can fetch only the data you need. It's longer than using array.length, but it means less data needs to be transferred during the request. This is the SQL alternative. So they are saying to fetch latest invoices. We have already used this. Fetch card data. Okay, we have to use this function inside. Also import this from data, and we can use define a variable card data. Await, then fetch card data. Okay, these are our cards. Let's uncomment these cards. Wait, let's uncomment them one by one. Total paid invoices. Okay, so they have done this. First, invoice count promise. They have used SQL command. Select count from invoices. Select count from customers. Select then sum. Okay, they have used the SQL commands. Okay, they have returned the required values from this. So we have card data. We can use card data dot, right, and we can use here, here, and here. Let's see if something happened. Okay, cool. So we have also used the cards collected, pending, total invoices, total customers. Great. So as you can see, our dashboard is slowly building. So it's taking its shape. We have revenue, invoices, and dashboard. So You can see it's almost completed, but we can still do so many things. So our dashboard is almost completed. So this was the solution, fetch car data. Okay, alternatively we can just destructure this into this, right? And we do not have to use this car data. So it will still work. Okay, right. So what next? Great, now you have fetched all the data for dashboard overview. Your page should look like this. So exactly our page is looking like this in our local host. Now there are two things you need to be aware of. The data requests are unintentionally blocking each other. Okay, creating a request waterfall. By default, Next.js pre-renders route to improve performance. This is called static rendering. So if your data changes, it will not reflect in your dashboard. Let's discuss number 1 in this chapter, then look into detail at number 2 in chapter 2. Let's read that again. Data requests are unintentionally blocking each other, creating a request waterfall. Okay, so they are unintentionally blocking each other. So how we can fix that so that you don't block each other? What are request waterfalls? It is a sequence of network requests that depends on completion of previous request. Okay, suppose first it will fetch revenue, then it will wait till this is completed, then after that fetch latest invoices, fetch card data. This is sequential fetching, this is parallel fetching. Great. So you can see it's almost taking 1/3 of time, so almost half of the time. For example, we need to wait for fetch revenue. To execute before fetch latest invoices. Okay, okay. So first, this data, this API call will be made. We will wait for this request, then wait for this request to complete, then after that this request will be made. So this is the waterfall. This pattern is not necessarily bad. There may be cases where you want waterfalls because you want condition to be satisfied before you make next request. You might want to fetch user ID and profile information first. Once you have ID, you might proceed to fetch your list of friends. In this case, each request is contingent on data returned from previous request. However, this period can also be unintentional and impact performance. Parallel data fetching. Okay, now we'll explore how we can fix the waterfall problem. In parallel, okay, initiate all requests in parallel. JavaScript, you can use the promise.all or promise all settle function to initiate all promises at the same time. For example, in TS, we were using promise all in fetch card functions. Okay. Yes, we are doing that in the data.ts. Okay, we're using promise.all. By using this pattern, you can start executing all data fetches at the same time, which can lead to performance gains. Use a native JavaScript pattern that can apply to any library or framework. However, there is one disadvantage of relying only on JavaScript pattern. What happens if one data request is slower than all others? So we have completed chapter 7. We have learned about some of the different ways to fetch data in Next.js, like from SQL, and we have stored the database in Postgres. So now they will look at the detail number 2 in the next chapter. So what it is by default Next.js pre-renders routes to improve performance. This is called static rendering. So if your data changes, it wouldn't reflect it in your dashboard. This is also a problem. Okay, how we can fix that? We will learn in chapter 8, static and dynamic rendering. Learn about how you can use to further optimize data fetching with PPR and streaming. Okay, this is chapter number 8. Okay, so we are at chapter 8, static and dynamic rendering. In previous chapter, we fetched data from dashboard overview page, and where we briefly discussed two limitations of current setup. Requests are creating an unintentional waterfall. Dashboard is static, so any data updates will not reflect in your application. Wow, great. That's so we are going to dynamically push the data. The topics we will cover here is what static rendering is and how it can improve your application's performance. What dynamic rendering is, when to use it, different approaches to make your dashboard dynamic, simulate how a slow data fetch to see what happens. What is static rendering? With the static rendering, data fetching rendering happens on server at build time. When you deploy, okay. So data is already fetched and rendered when we deploy or during revalidation. Result can be distributed and cached in a content delivery network or CDN. Okay, this is a diagram for that static rendering. Okay, so this is the data, and okay, so this is the request, this is the users, and this is the data. So this is a cache. When there is a cached data, it will fetch the data, or like every time cache data is used on each request. Do not have to fetch data on each request, but when it is uncached, data is fetched on each request, so making it inefficient. Whenever a user visits your application, the cached result is served. There are a couple of benefits of static rendering. Faster websites, pre-rendered content can be cached and globally distributed. Okay. This ensures that users around the world can access your website content more quickly and reliably. Okay. Reduced server load because the content is cached. Your server doesn't have to dynamically generate content for each user request. So that is another very big benefit of reduced server load, because we have already our cache data is already put in content delivery networks that are near the user's area or near the user's region. So request will be data, or I can say websites, will be served more quickly. Server load be less in that case. So SEO, third is SEO. Pre-rendered content is easier for search engines to crawl, so index. Okay, pre-rendered easier for search engines to index as content is already available on page loads. This can lead to improved search engine rankings. Static rendering is useful for you with no data that is shared across users, such as static blog post or product page. It might not be good fit for dashboard that is personal data that is regularly updated. So in the dashboard, static rendering is not very beneficial because it's not a blog or it's not a product page. Like this, invoices count can change in real time, customers can change, This graph can change, right? Opposite of static rendering is dynamic rendering. Why is static rendering not good for dashboard app? Because application not reflecting the latest data changes. Now comes the dynamic rendering. What is dynamic rendering? With dynamic rendering, when it is rendered on server, on each user request at request time, when the user visits page, there are a couple of variants of dynamic rendering. Real-time data, dynamic rendering allows application to display real-time or frequently updated data. This is ideal for applications where data changes often. Use specific content. It's easier to serve personalized content such as dashboards or user profiles and update the data based on user interaction. Request time information. Dynamic rendering allows to access information that can only be known at request time, such as cookies or URL search parameters. It's time to quiz what content information can only be known as request time. Okay. Dynamic rendering allows information that can only be known at request time, such as cookies or URL search parameters. Now let's make our dashboard dynamic. By default, it doesn't set its own caching semantics. This allows the framework to set its own static and dynamic behavior. Okay, you can use Next.js API called unstable, no stored inside your server components, or data fetching functions to opt out of static rendering. Let's add this. First, we have to import unstable no store inside our server, inside this data fetching function. Unstable no store as no store. So add no store here to prevent the response from being cached. This is equivalent to in fetch cache no store. Okay, no store. We will call it here no store. So it will prevent the data from being cached. So we will opt out of static rendering in this. Okay, we have to use it everywhere. Okay, we have to use it inside every function. Before try. Okay, just after, just at the top of each function. I think these functions we will use later. Fetch customers. Fetch filtered customers. I think we will use these functions later in this course. Okay, it's only to be updated to up to fetch invoice. I don't need to add this in the last three functions, only up to fetch invoice by ID. So okay, we have added no store functions. So now simulating a slow data fetch. Let's do this. So we will now simulate a slow data fetch. Making the dashboard dynamic is a good first step. However, there is still one problem we mentioned in the previous chapter. What happens if one network is slower than all the others? Okay, now we will simulate a slow data fetch near data. It is uncomment the console.log and timeout set timeout inside fetch revenue. Okay, we will uncomment this. Also uncomment this console log Data fetch complete after 3 seconds. So now we will go to dashboard in a new tab and notice how the page takes longer to load. In your terminal, you should see the following messages. Okay, let's open the terminal. Open this dashboard in the new tab. Okay, it took some time. Here you have added an artificial 3-second delay to simulate a slow data fetch. The result is that now the whole page is blocked. Yes, exactly. Our whole page was blocked for some time. Common challenge developers have to solve. With dynamic rendering, your application is only as fast as your slowest data fetch. Okay. Even dynamic rendering has some problems. With dynamic rendering, the application is only as fast as your slowest data fetch. So if our slowest data fetch is so slow, our application will be also so slow. Nice, you haven't learned about static and dynamic rendering in Next.js. Now we will learn how to improve your user experience by adding streaming. Next, we will learn about streaming. In the previous chapter, you made your dashboard page dynamic. However, we discussed how to slow data fetches can impact the performance of your application. Let's look how you can improve the user experience when there are slow data requests. What streaming is, when you might use it, how to implement string with loading.tsx and suspense. We're going to use loading, tsx and suspense, react suspense. What loading skeletons are, what route groupers are, and when you might use them. You have to place suspense boundaries in your application. Okay, this is some lengthy chapter. What is streaming? Streaming is a data transfer technique that allows you to break down a route into smaller chunks. Okay, route into and progressively stream them from server to client as they become ready. Okay, we will have to first wait these chunks to become ready and then stream them from server to client. Like here, partial content with loading state, suspended content streaming in. Okay, there is so much happening right here. We will get to know about this later in this chapter very deeply. By streaming, you can prevent slow data requests from blocking your whole page. Right? This allows you This allows the user to see and interact with the parts of page without waiting for all the data to load before any UI can be shown to the user. Okay, so they have given an example. Is fetching data on server. Cards. So cards will take the lowest time to fetch data, rendering HTML on server, then loading code on client, then hydrating. So they have given example of the three datas like revenue, invoice and cards. And so latest invoice has more data, it will take more time fetching data on server. But another things like rendering HTML on server, loading code on client can take almost the same time. So only difference is fetching data on server. So okay, streaming works well with React's component model as each component can be considered a chunk. Okay, there are two ways to implement streaming Next.js at page level with loading.tsx file. Okay, for specific components with suspense. Let's see how this works. Not quite. Junction and parallel. Okay, one you can significantly reduce your page overall loading time. Okay, right. Streaming. Streaming a whole page with loading.tsx. Okay, in app dashboard folder, create a new file called loading.tsx. In the dashboard, they are saying just in dashboard, create a new file loading.tsx. And create a file name and copy this code. So this is also React component. So let's see what it will do. Refresh localhost and you should see it now. Okay, loading. Okay, it is still loading. It's taking some time to load the data. So let's see what they are trying to do here. Few things are happening here. Loading.tsx is special Next.js file built on top of suspense. It allows you to create fallback UI to show replacement while page content loads. Okay, so while the data was being loaded, it was showing the loading window. The loading skeleton, I can say. Since sidebar is static, it's shown immediately. Okay, so user can track to the sidebar if the dynamic content is loading. Let's see this again in action. So our data is loaded, so our components are not now shown on page. The user doesn't have to wait for the page to finish loading before navigating away. This is called interruptible navigation. Okay, so congratulations, you are just implemented streaming. Okay, we have implemented streaming. Okay, without streaming, what will happen if I just delete this? Let's see what happens. Okay, so the page is still loading, like whole page is blocked, right? But now if I use loading.tsx, and then copy the same code, now open a new tab, close this, copy this URL. Okay, our sidebar is immediately loaded. So that means, okay, we can also then create loading.tsx files inside this, and they will then individually load, right? If I'm not wrong. Okay, now we will add a loading skeletons. It is a simplified version of UI. Many websites use them as a placeholder or fallback to indicate user that a content is loading. Any way you embed into loading will be embedded part of static file and sent first. Then the rest of dynamic content will be streamed from server to client. Inside a loading.tsx, the import a new component called dashboard skeleton. Okay. This is the skeleton. This is a skeleton for card, and they have added the loading animation here, named it shimmer. Okay, right. So after that, we will use this here, dashboard skeleton in our loading.tsx. Now we will see this. Let's try this. Copy this, open a new tab, close this, and paste the URL here. Okay, now it's working. So it has skeletons for everything, even cards, invoices. Great. It's not even out of the place. I mean, they're on the same thing, right? This is great. This is amazing. That's great. So we have added the skeletons, and now what's next? Okay, we can change this with route groups, create a new folder called overview inside dashboard, and move your loading and tsx and page.tsx file inside folder. Okay, we'll create a folder named inside circular brackets. We will name it overview, and we will move our layout. What they're saying, why this error?